Hello. So today's problem is you will be provided with two integers n comma k, and you have to construct a binary string Sn where s of I equals to s of I minus 1 plus 1 plus inverse of s of I minus 1, right? And the base condition is given as when n equals to 1, you have to return 0, right? This is the base condition. Now let's find out the pattern that when s1 its length is 1, right? For s2 its length is 3. For s3 its length is 1 2 3 4 5 6 7, right? 7. For s4 its length is 15. s4 it's 15. Can you find a pattern? It's all of them are 2 power, it's 2 power 1 minus 1, it's 2 power 2 minus 1, it's 2 power 3 minus 1, it's 2 power 4 minus 1. So basically whatever the value of n is provided, it's 2 power n minus 1. So the string length is 2 power n minus 1, right? Now say this is s4. If this is the string length of 15, right? For middle index it will be 1 always. For whatever string, if it is middle index it will be 1. If it is middle index it will be 1. If it is middle index it will be 1. For s1, for base case it will be 0, right? So how to find out the middle index? So middle index formula will be length by 2 plus 1, right? So for this one 15 by 2 plus 1, that is its integer division, so 8, right? 7 plus 1 8. For this one also 7 by 2 plus 1, that is 4. For this one also 3 by 2 plus 1, that is 1 plus 1 equals to 2, right? Yeah. So you have got middle index. Now the conditions will be, 3 cases will be: first, if middle index equals to k, right? Then just return 1. You can see if middle index equals to k, then return just 1, right? If k is less than middle, then you can let's erase all of them. This is the mid. Now say if k value is here, it's basically the same. It's basically the string 3 only. That means it's s of n minus 1, and you can reuse the k value. No need to change the index. So you have to return, say this was the function of n minus n k, then you have to return f of n minus 1 comma k, right? Because it's basically the previous string of n minus size, it's the string n minus 1, and k value will be the same. If it is 6, that means for s3 you have to use that. If it is 2, that means for s3 you have to use 2. So all values are just same, right? Yeah. Now the tricky part is for k value greater than mid. In this case, here they have said it is reverse of inverse of s of I minus 1. That means whatever was there for s of I minus 1, you have to first inverse that, then you have to reverse that, then you will get the value, right? So what is inverse? If it was 0, it will be 1. If it is 1, it will be 0. Basically flipping. Now let's consider for reverse. So if you are mentioned with the index k, say for this example, you are given for index k equals to 13. Then if you reverse this part, then it will be from right to left. From right to left, it will be this one: 15, 14, 13, 12, 11, 10, 9, right? So you will get this string. Now again, if you do inverse, if you just have to flip this, each of them. 1 will be 0, 0 will be 1, 0 will be 1, and so on. So for say, let's erase them. So for n equals to 4 and k equals to 13, it's here k is greater than mid. So you have to reverse and you have to inverse. Instead of simulating all these things, let's directly get the value of let's use recursion and get the value from S3. Before that, you have to find out the index for S3 itself. Now you can see the value will be 1 and the index with respect to this will be 3. So for k equals to 13, it is 3. So the mirror index, this is the mirror index, it's called. So for the mirror index will be whatever length you are given minus k plus 1. This is the formula for mirror index, right? Now just calling recursion of n minus 1 comma mirror index itself is not enough. Why? Because there is a part of inverse. It's basically flipping. So whatever it will return, if this returns 0, then you have to return 1. If this gives you 1, you have to return 0. So the third case will be for third case, when k greater than mid, you have to find out the mirror index, which is length minus k plus 1. Then you have to return just basically this function f of n minus 1 and mirror index. And whatever this function will return, you have to flip that. That means if f equals to 0, then you have to return 1. Otherwise, you have to return 0, right? So this part is doing the inverse operation. So let's go to the LeetCode and solve this question. So let's solve this question. As it's mentioned that the base s1 equals to 0 and the return type is character. So the base case will be when n is of size 1, then return 0, right? Now when it will be when the k value will be middle, then we have to return 1, right? So if k equals to mid, return 1, right? So before this, we need to find out the middle index. So first calculate the length. It will be basically power of 2 comma n minus 1, right? And in middle will be length by 2 plus 1, right? So we have covered case number 1. Then let's cover case number 2 for left side. It will be basically just s of I minus 1. That means if k less than mid, return this function, this recursive function with n minus 1 and k, same k value. Otherwise, right side, that means we have to do reverse operation, also inverse. That means first calculate the mirror index in it will be length minus k plus 1 and return the same function, recursive function with mirror index. Just pass the value of mirror index. Also you have, this is just a reverse operation, you have to do inverse also. So whatever you will get, compare. If it is 0, return 1, otherwise return 0. Now let's check. Yeah, let's submit this one. Okay.